Hi, welcome back. Today we are going to be looking at a couple of rules for us today. One is what we call the special trig, and the other one is called the squeeze theorem, although we might get into that the next day. We'll see how far we get. Yesterday, you might recall, we reviewed some basic limit problems. Remember, the limit tells us what the value of the function is approaching. Remember, this is not the value of the function itself, but what the value of the function would be if we could substitute in. If the limit of the function equals the value, remember we call that a continuous function at that point. Ideally, we would get the same when we substitute any number into a function. For example, let's let f of x equal sine of x. We can, of course, plug in any number into the domain into x and get the value of f of x. For example, let's let x be 0. If we want to find f of 0, we would get the sine of 0, which we would get 1. And that's our substitution technique. Therefore, what would then the limit as x approaches 0 of sine be? Well, it would be the same. It would also be 1, because at x equals 0, sine is a continuous function. We would say, again, this function is continuous at x equals 0. However, as we recall from pre-cal, not every function has an infinite domain. Let's look at the function sine of x over x. What would happen if we plugged in x equals 0? So let's try that. F of 0, we would get sine of 0 over 0, which becomes our problem, 0 over 0. That's indeterminate. And as we talked about yesterday, that's not very good for us because it really doesn't define what the answer is going to be. So let's take a look at the graph. I graphed sine of x below here. So we can think, well, what can we say the values approach as x approaches 0? So we take a look at here. Well, if we approach from the left-hand side, the value looks to be approaching 1. Be careful of the scale. If we approach from the right side, the value also approaches 1. So we can say that the limit as x approaches 0 from the left is 1, and we can say that the limit as x approaches 0 from the right is equal to 1. So yeah, therefore, we can actually say that the limit as x approaches 0 of, let me go and write this out, of sine of x over x is just 1. And we talked about a rule. That's just because the limit from the left is the same as the limit from the right. Well, that's going to lead us to a few rules for us, and we're going to discuss them today. These are the special trigs. And our first one is, well, what happens as sine of x over x approaches, as x approaches 0 of sine of x over x? Well, we just showed that that's equal to 1. How we actually prove it is using something called the squeeze theorem, which we're going to talk about later. So that's just going to equal 1. Now, also, if I flip it, what would be the limit as x approaches 0 of x over sine of x equal then? Well, if I flip sine x over x, this is just 1 over 1. If I flip it, I still get 1 over 1, or just 1. So these are the same right there. Tangent of x over x is also going to be 1. Tangent follows sine for the most part. It turns out if we were to graph the 1 minus cosine of x over x, as x approaches 0, this becomes 0. This one's pretty boring. We don't see it too often. So these are our special trig rules that we're going to look at today. So let's look at a few examples. Number 1, we want to find the limit as x approaches 0 of sine of 5x over 4x. Now, one thing I want you to be aware of, notice in our rule up here, these must be equal. They must be the same. So if I have sine of 5x over 4x, they cannot be the same. So these aren't the same here, I got to do some algebra rules to kind of help out. But what I'm going to do is I'm going to factor out the 4 out here. I'm going to factor that out. And I'm going to now rewrite this as the limit as x approaches 0. You know what? I'm going to put it to the front there. Sorry, I meant to put that in the front. So we're going to get this 1/4 times the limit as x approaches 0 of sine of 5x over x. Now it's better. See, now I can get this x here to be a 5. So I am going to think, well, what am I missing? Well, remember, these x's have to be the same. This 5x I can't change, but this needs to be a 5x. And I can easily make that a 5x if I just multiply the bottom by 5. So I'm going to multiply the bottom by 5. Now in doing so, we also have to multiply the top by 5. That way we don't change the value. Now this 5 belongs to this x. So when I rewrite it now, I'm going to get this 1/4 sine of the limit as x approaches 0 of sine of 5x over 5x, and I still have this 5, this leftover 5 here. So I'm just going to write it off to the side right there. And now we're pretty much done with this one. Our rule that we just learned, well, because these are the same, x and x, these are the same x values, this whole limit here is just going to be 1. But I'm still left with that 1/4, and I'm still left with that 5. I can just bring it down, and that becomes 5 over 4. And that's what our limit approaches there. Very cool, very easy to do. Let's take a look at number 2 here. Now for number 2, oh look, I want sine of x over x or x over sine of x. I want one of those. So ask yourself, do you see that in question number 2? And the answer is yes. If I look right here, I got my sine of x over x. So the question is, well, how can I isolate that? So to do that, because I'm dividing by a single number, if we divide by a single number, I can split my fraction. In other words, I can write this as now the limit as x goes to 0, 2x over x plus sine x over x. And yes, these two x's cancel. So what we're left with is 2 plus, remember this is our rule, what is sine of x over x going to become? Our rule says that's just going to become 1, and then what's 2 plus 1 is, whoops, almost went on there. This becomes 3, and there's our answer. That's an easy one. Don't miss that one. All right. The hardest one we see is number 3. This one's a tough one right there. Because if you notice, we have sine of 3x over this sine of 2x. So I'm thinking, remember, I want sine of x over x or x over sine of x, as long as these are the same. So I'm going to go here and see if I can see that anywhere. And I really don't see it until I look really close. Over here, I have this 2 over sine of 2x. If this 2 had an x on it, I can make that equal to 1. So we're going to do some little bit of algebra here. Okay? Just a little bit. When I rewrite this, we get the limit as x approaches 0 of 2 over sine 2x. I'm just going to isolate what I already have. Now I'm still stuck with this sine of 3x over 1. Right, like so. So now all I have to do is think about, well, what is it that is missing here? Well, the first one, this one needs an x. I don't need an x. I have plenty of x's. This one needs a 3x. If this had an x, this would be 1. If this had a 3x on bottom, it would be a 1. And I can easily get those by using what I know from math. If I multiply the top and bottom by the same number, I really don't change the fraction. So because this needs an x, I just have to multiply both top and bottom by x. Because this needs a 3x, I just need to multiply top and bottom by 3x. There's a shortcut for this. This x now belongs to this 2. So I'm going to rewrite it. The limit as x goes to 0, 2x over the sine of 2x. This 3x belongs to here, to the sine of 3x plus 1. And that's going to give me the sine of 3x over 3x. And then I just think, okay, what's left over? Remember, to get this to be a 2x, we had to multiply it by x, which means that changed the function, so we divide by x to fix that. So I'm still left with this 1 over x here. Remember, to get this to be a 3x on bottom, we also have to multiply the top by 3x. So on over here, I'm left with this 3x over 1. Those x's will cancel out. And then let's see what's left. Well, now I got what I want. This is just 1. This is just 1. Remember, as long as these are the same, it's 1. And this just simplified to 3. So what do we get for our answer? Just 3. Pretty easy to do. Kind of fun. I like these. They're a little bit more algebraic, a little bit more fun. All right, now for an example like number 4, again, I want to get either sine of x over x or x over sine of x. So for a question like number 4, I want to be able to get that. So I start thinking, how can I get that? The bottom I can factor out an x. And if I do that, take a look at what we're left with. We got this sine of x over x. We got exactly what we wanted. So this becomes the limit as x approaches 0, sine of x over x times, and now what's left over? 1 over x plus 2. Our rule says that that part's just 1, and if I plug 0 in here, let x be 0 here, we get 1/2, so we get 1/2 for our final answer there. All right, watch this video again if you like this, if you want to see it again, okay? Smash that like button. I'll see you next time on Squeeze Theorem.